This podcast is on calculations involving pH and something we're going to call pOH. These are common calculations in acid-base systems. You need to remember that the pH is defined as the negative of the log to the base 10 of the concentration of H+. And remember that those square brackets mean concentration and that we're dealing with molarity. An example, if H+ was 1 times 10 to the minus 10 molar, then the pH is the negative of the log of 1 times 10 to the minus 10. The log of 10 to the minus 10 is minus 10 times negative 1 gives me a pH of 10. Little more realistic example, if the H+ was 1.8 times 10 to the minus 5 molar, then the pH is the negative of the log of 1.8 times 10 to the minus 5. The log of 1.8 times 10 to the minus 5 is negative 4.74 times negative 1 equals 4.74. And here we're going to work through and show you how to do them on the calculator. To do the calculation in your TI-84 calculator, you need to input the 1.8 times 10 to the minus 5, and we need to take the negative log of it. And one of the easiest ways to do this is to use the calculator to its full advantage. Negative log, and then you get the parentheses, and then we want 1.8 second comma, which puts in the enter exponent, negative 5, close the parentheses, and when you hit enter, we get the value of 4.744, which is, to 2 sig figs, 4.74. Try these on your own. What you need to do is do the calculations, stop the podcast, write down your answers, and then check them. Assuming you've done so, the log of 0.15 is negative 0.82, so here we have a pH of 0.82. Notice that it is less than 1. And in the second case, the negative of the log of 3 times 10 to the minus 7 is 6.52 for the pH of that one. Well, sometimes we're going to go the other way. If you take a pH meter and put it into some cool Diet Coke, you're going to find it reads 3.12. Well, what is the concentration of H+? Because pH is the negative log of H+, it then follows that the negative pH equals the log of H+. If we take the antilog, or raised to 10 to the x, of both sides, we get 10 to the negative pH equals H+. Since pH was 3.12, 10 to the negative 3.12 is H+, and using our calculator we can solve, and we get 7.6 times 10 to the minus 4 molar. Now, as you're looking for how to find an antilog, or 10 to the x, you just look for the shift or the second function button on your calculator. The following example, using the calculator, will illustrate this. To calculate the H+ concentration for the Diet Coke example, where the pH was 3.12, you need to take the opposite of taking the log, which is raising it to the power of 10. Second log gives you 10 to the x. Some people call that the antilog. 10 to the x of the negative pH is negative 3.12. Close the parentheses, and we get our answer of 7.585 times 10 to the minus 4, or 7.6 times 10 to the minus 4 molar. Now, on your own, a solution has a pH of 8.5. What is the concentration of H+ in that particular solution? Again, stop the podcast and try it for yourself. Ten to the negative pH is equal to H+. 10 to the negative 8.5 gives me a value of 3.16 times 10 to the 9 moles per liter. So that is going the other way. You will remember, I hope, that water can function as both an acid or a base. And in pure water, there is what we call autoionization, where the H+'s transfer themselves around, and we end up with an equilibrium occurred, where the Kw is equal to H3O+ times OH-, which is the value of 1.0 times 10 to the minus 14. Well, moving on and using that, you, I hope, will remember that since the Kw is H3O+ times OH-, and indeed they multiply to give you that 1.00 times 10 to the negative 14. In a neutral solution, H3O+ equals OH-, and they both equal 10 to the negative 7. And the pH at 10 to the negative 7 is going to be 7 for the neutral solution. And since acids and bases are opposites, pH and pOH are opposites. Now, pOH doesn't really exist, but it's very useful for calculating or determining the pH of basic solutions, or indeed the H plus concentration in a basic solution. It looks at the perspective of a base. pOH is equal to the negative log of the OH minus concentration. And since pH and pOH are on opposite ends, and due to log theory, it turns out that pH plus pOH equals 14. So if you know the pH, you know the pOH, and vice versa. So, what's the pH of a 0.0010 molar solution of sodium hydroxide? Well, the concentration of OH minus is 1.0 times 10 to the minus 3 molar. So the Kw is equal to H3O plus times OH minus. And in the traditional way, we can go ahead and calculate and find that the pH is going to be 11. However, there is an easier way. The pOH is the negative log of 0.0010, which is equal to 3. And the pH is 14 take away 3, or 11. And this is a much more simplistic way of doing it, using the concept of the pOH to calculate a pH. So, the pH of rainwater collected in a certain region of the United States on a particular day was 4.82. What's the H plus concentration of that rainwater? pH is equal to 4.82, and so H plus is 1.51 10 to the minus 5 molar. That's pretty straightforward. However, the hydroxide ion concentration in a sample of blood turns out to be 2.5 times 10 to the minus 7 molar. What's the pH of the blood? The pOH is going to be 6.60 as you calculate it, which means that the pH is 14 take away 6.6, or 7.4. And it turns out, in fact, that the H plus concentration is 4.0 times 10 to the minus 8. And so as you can see, the use of pH or pOH is very useful in these kinds of situations. And again, you can watch it in the calculator. When you compare acid and base solutions from the standpoint of pH, if it is below 7, it's acidic. If it's above 7, it's basic. The opposite is true for the pOH in the far column. If it is basic, the pOH is less than 7, and the pOH is greater than 7 when it's acidic. Likewise, in an acidic solution, the H plus concentration is above 10 to the negative 7. When it's basic, it's below 10 to the negative 7. Likewise, in a basic solution, the OH minus concentration is above 10 to the negative 7, and in an acidic solution, the OH minus concentration is below 10 to the minus 7. You need to keep these things in mind as you work with pH